Hi guys, welcome back to my channel. In this video, we're going to look at the topic text, sound, and images. And at the end of this lesson, you should be able to understand how computer represents text, sound, and images. You should also be able to understand character sets, including Ascii code and Unicode. Also, you should understand the definition of sample rate and sample resolution, the effect of the resolution and color depth on images. Now, let's go to character set. So, when we type a message or we want to save a file in the computer does not actually store letters. What it stores is numbers, which is binary number, and that is represented in form of zeros and ones because that's the only language that a computer understands. So now, what is the meaning of character set? It's a collection of characters that a computer can recognize and store. So basically, we can say that a character set is like a dictionary that maps each character to a unique binary code. For example, a letter A will be stored as 01000001. The @ symbol will be stored as 01000000. So basically, when the computer wants to use or want to save any text, what it will do is it will look into this dictionary and check what does character A represent in binary, and then it obtains this binary digit and store this in the computer. So same thing when when the computer is storing data and the computer is displaying data. So that is character set. Now let's look at Ascii code. So Ascii code is one of the most commonly used character sets, okay, and it stands for American Standard for Information Interchange. So this Ascii code is something like this, okay. It represents English characters using 7 bits. So when we say 7 bits, basically means we can only have 128 possible characters. And we also have an extended Ascii code which uses 8 bits, so meaning that we can have 256 characters. So for example, character A, the binary number would be this. Character B, the binary number would be this. When the computer needs to store or display any of this character, it will look into this dictionary to check. Okay, if it needs to display, it checks what the binary number is for each character and then use that to display or store text. Now, Unicode. So basically, because Ascii code is limited, we can only represent about 256 characters. That means that we cannot represent all languages of the world in the computer system. So now we have Unicode. So Unicode is a universal character that can represent characters from all languages, such as Arabic, Chinese. It can represent emoji, even mathematical symbols, currency symbols, and so on. And that's because it uses up to 32 bits. So we can have more characters. Okay, for example, this emoji, this is the binary digits. Now let's look at representation of sound. The same way we can store text in the computer system, we can also represent sound in the computer system using binary. So sound travels as a wave in the air. So meaning that when a sound is produced, it actually produces, it goes in form of waves. And these waves vary in height. Okay, the waves vary in height. So this is what we call amplitude. Amplitude, the loudness of a sound. Okay, the louder the sound, the higher the wave. Okay, so amplitude specify the loudness of the sound, and how fast they vibrate, that is what we call frequency. How fast a sound vibrates is what we call frequency. Now let's look at the meaning of sampling. Sampling means measuring the amplitude of the sound wave. Remember that amplitude is how loud a sound is. Okay, so sampling means measuring the amplitude of the sound wave, capturing the height of a wave at regular intervals. So this process is called sampling. Now, for us to be able to sample a sound, we need what we call ADC, analog to digital converter. Computer can only understand digital data, okay, which is binary, and the sound is analog. So a digital converter will convert the analog data, which is sound, to digital data, which is binary. So how is sampling used to record a sound clip? So the first step is that the amplitude of the sound wave is determined at set time intervals. Basically, we need to find the loudness of the sound at time intervals. Maybe in 1 second, what is the level of the sound? So after finding the level of the sound, then an approximate value is stored. Let's say at this point, the amplitude is 9.9. Okay, so an approximate value. So we need to approximate. Let's say we approximate to 10. And this value is stored. Of course, before this value is stored, it has to be converted to binary. Okay, because this is denary. It has to be converted to binary. And then this binary data will be stored in the computer system. When it comes to measuring of sound, the range we use will determine how accurate is the sampled sound. The higher the sound amplitude, the more accurate is the sound. So for example, instead of stopping at 10 here, if we extend this range to 1000 and we store this in the computer system, then the sound that will be stored will be more accurate. Now let's look at sampling resolution and sampling rate. There are two things that affect the sound quality. The first is sampling rate and sampling resolution. Now, what is sampling resolution? Sampling resolution is also called bit depth. Okay, it is how many bits that is used to store each sample. How many bits that is used to store each sample. For example, if we are using 4 bits to store a specific sample and we are using 8 bits to store another sample, this sample will have higher accuracy compared to this sample. So the more bits that is used, the better the accuracy, and of course the larger the file size. Now, what is sampling rate? So sampling rate is how many times we sample the sound every second. How many times we sample the sound every second. And this is measured in hertz. And 1 hertz means 1 sample per second. Now let's look at representation of images. The same way we can store text and sound in the computer system, we can also store images digitally. So an image are made up of pixels. They are made up of tiny dots called pixels, and we said that an image is a 2-dimensional matrix. Okay, a 2-dimensional matrix with length and height. Now, each pixel holds a specific color. So if you have an image and it is broken down into pixels, each pixel will hold a specific color. And this pixel can take different shapes, such as a square or a circle. So the more pixels an image has, the more detailed it appears. This is also known as image resolution. So each pixel that is stored in the computer system has a series of binary numbers. So when a black and white image is used, it means that we only require 1 bit. So 1 bit means that 2 raised to power 1, that means we have 2. So that means that we are using 2 colors. Okay, and a 0 represents black and 1 represents white. So if each pixel represents 2 bits, so from an image, if each pixel has 2 bits, it means that we can come up with 2 raised to power 2, we can come up with 4 colors. So because we can use 2 bits, we can come up with 0, 0, 0, 1, 1, 0, 1, 1. If each pixel is represented by 3 bits, then we can come up with 2 raised to power 3, 8. So it means that we can come up with 8 different colors. We can use 8 different colors to represent the image. So what is color depth? Color depth is the number of bits that is used to represent each color. So 1 bit color depth means 2 color. Okay, 2 raised to power 1 is 2. 2 bit color depth means 4 color. That is 2 raised to power 2. We have 4 colors. 3 bit color depth means 2 raised to power 3, and then we have 8, and so on. So modern computers have 24-bit color depth, which means that we can have over 16 million different colors can be used to represent an image. So when increasing color depth also means that we are increasing the size of the file when we are storing image. The higher the color depth, the higher the file size. Now, image resolution. Image resolution refers to the number of pixels that make up an image. Remember, we said that when an image is to be stored into the computer system, it is broken down into pixels. Now, the higher the number of pixels, okay, the more quality or the higher the resolution of an image. If you look at this car wheels, okay, we have 5 car wheels. Look at wheel A and wheel E. Wheel A has higher image resolution compared to wheel E, and that is because more pixels is used to represent wheel A in the computer compared to wheel E. So photographs with lower resolution, we have less details compared to image with higher resolution. So what are the drawbacks of using high resolution images? The first one is that when we increase the number of pixels, it means that the file size will also increase. The file size will increase. Also, when we increase the number of pixels and the file size increase, that means it's going to take time when downloading or transferring the file. A file that is 1 GB compared to a file that is 5 GB. When these two files are downloading, 1 GB will download faster and also upload faster compared to 5 GB. So that is the drawbacks of using high resolution image. Okay, so that is the end for this lesson. If you want to understand this topic even better, watch the video Topical Past Year Questions.